In this video, I'm going to give you an overview of this broadcast radio network management example, which uses Kuwaiba and OpenNMS to respectively store the inventory for the site and to monitor the site. The project itself is a Docker Compose project, and if I jump into Docker Compose, you can see that this is the actual Docker Compose network. We're simulating 4 sites, so we have 4 minions, each at a different location, but the sites themselves have overlapping address space in the 192.168.105 subnet, and so these devices will be replicated across all 4 sites. And the devices themselves are being simulated using SNMP sim, which uses SNMP walks from the device to render up data as if the device was responding to the minion whenever the minion makes the SNMP GET request. Also in this example, we have NGINX as a front end, which gives us an entry-level page. And then we have behind NGINX, OpenNMS Core, Grafana, Kuwaiba, which is obviously the inventory system, and something called the Provisioning Integration Server, which allows us to integrate OpenNMS with Kuwaiba and pass data backwards and forwards between the two. If I look at the docs, just to give you an idea of what we're monitoring, it's one of many local radio stations, and this is a diagram of a typical site with broadcast receivers, transmitters, and program input equipment, which responds to silence from the input and will play out alternative sources if the normal source disappears. We have a FM transmitter and we have a DAB transmitter on site, which feeds into an aerial which is also fed by other broadcasting stations. We also have a power, top of rack power device and a switch that pulls it all together. I have a diagram here of the rack and also Kuwaiba's rendering of the rack beside it, which allows us to position equipment in the rack and show what the thing actually looks like on site. So that's what we're monitoring. Let's jump to the actual example. So this is the front page that you get from NGINX if you go to index.html, and it gives us links to go to the OpenNMS, Kuwaiba, and Grafana. It also gives us some links to get data from Kuwaiba, and it gives us a couple of buttons that allow us to send events into OpenNMS to ask it to import the requisition from Kuwaiba through PRIS. So let's start by looking at Kuwaiba. And this is the standard Kuwaiba page. If I go to navigation, you can see that at the root there are a number of sites and devices that pre-exist in Kuwaiba as part of the standard build that comes with the container. I haven't removed those. I've just added this Europe continent, and then within that the United Kingdom, and under that Hampshire and Wiltshire, and within these I've also put the radio sites. So Portsmouth is the most comprehensively modelled site, and if we look at Fort Whitley, we can see that it has a rack, and within the rack it has broadcast equipment. And there is also a DAB encoder shelf, which has more equipment actually on the shelf within the rack. If I jump back again to the main site, if we look at views, we can look at an object view of this site, which just gives us an overview of the connections between the equipment. The other sites in this example, I haven't put in the connections. I've only put IP addresses for the equipment, but this just shows you what you can do if you go to the trouble of actually putting in the wires that connect up this equipment to get a topology of how it all fits together. We can also see a rack view here, which shows us the position in the rack of each bit of equipment. And just to show you where that comes from, if I just click on this DAB receiver, you can see this receiver's got an audio input, audio left and right inputs, an Ethernet input and a mains input. These are obviously able to be connected up within the wiring diagram. But also you can see that it's in position 31 in the rack, and it takes up 1 unit. So that's how the rack display is built up, because each of the devices is given a position and is also put in the unit. The other thing to talk about is the equipment model. So I've selected DAB receiver. And you can see here, that's the selection. And if I go to the detail, that has a display name of DB7012-1. That display name is actually used by Grafana to determine which page template should be used to render up this type of device. So in this particular model, the way we're telling Grafana what it should show is by putting in the display name as part of the metadata that goes in with the device description in OpenNMS, and Grafana can use that then to say, yes, I know which page to render up to show this device. Okay, the final thing just to show on this is if I go to outside plant and I open up the radio stations view, you can see that the sites are on that map within Kuwaiba, and obviously the same data would be on OpenNMS at the same geographic locations. Okay, how does this data get exported? Well, if I go back to this front page, we can see that we've got links here that will make a request to the provisioning integration server. So let me open this particular one. You can see I'm asking for requisitions Kuwaiba UK. So the Kuwaiba UK requisition is going to make a call against Kuwaiba to get a CSV file back, and then the Prissa integration server is going to take that CSV file and turn it into this XML file that represents these devices, which are going to go into OpenNMS. And you can see on the example that for each device, we have the name of the device, the foreign ID, which is actually the Kuwaiba object ID for this device, a location, which comes from the IP address, I'll show you that in a second, and the interface address. Now, the interesting thing is that all of these devices exist in separate sites which are behind a NAT firewall. So within the site, the IP address of each of these devices is going to be overlapping with the same device on a different site because it's a private address space within the site. But the way we handle that is by using the location. And because each minion is designated to be at a different location, that minion can have an overlapping address space with a minion at another location. So we've got, this, for instance, Winchester site, Crabwood Farm is the location. It has 105.101. 105.101 is also used at the Portsmouth radio site, but in this case the location is Fort Whitley 1. We also include obviously the latitude and the longitude. We can include the category, which is telling Grafana which template to use. It also can be used by OpenNMS to change how it displays data. And then the display category, in this case, is the customer name, ILR contractor 1 in this case, but as you can go on down, you can see different customers are used for different devices. And some devices haven't got the information in, so the default information is used. Okay, so that was bringing in that data. We can also then import that requisition into OpenNMS. And if OpenNMS is up and running, and Kuwaiba has been running for a while, it's possible that you may need to import this requisition more than once when you first do it, because whenever Kuwaiba or Prissa restart, the web servers will not start up immediately unless you make a request to them. So you need to make one request to get the thing actually started, and then after that it will work fine. So I'm going to import that requisition into OpenNMS. It's imported the requisition, and if I go to OpenNMS, you can see that once it's imported the requisition, it will have about 44 nodes in it that have come in from Kuwaiba. It will also have these 4 minions. Each minion, as you can see, is on a different location. There you see Rye Ridge, there you see Camp Hill. So these devices are all also on different locations. These are all Fort Whitley. These are all Rye Ridge, which is on the Isle of Wight. These are in Winchester. These are in Salisbury. So the devices themselves may have overlapping address spaces, but the way we've done the naming for the devices, we can see where they are, and we can also see that they are on different locations. If we just go to the geographical maps, and we want to jump in here, you can see that these are the devices at that particular location. Obviously, we're very zoomed out, so I want to zoom right into the location. And if I get right down, now it's possible to set up the default location for a new user, but I'm not doing that in this example, so I have to hunt around a little bit. You can see that in this case I've got this particular site here, and this particular site shows you the devices that are on the site in the geographical view. So that's OpenNMS. Let me go back to this nodes view, and I'm going to pick one of these devices. So let me pick this DB7012 device, and you can see that when OpenNMS scans the device, it picks up the sysObject ID, which it uses to determine what data it should collect for this type of device. And if we look at the resource graphs for this device, and particularly at node level performance data, graph that selection, we'll see that OpenNMS is picking up the left and right values for particular ports on the device. It's pretty boring at the moment because honestly, the simulators are not generating dynamic data. They're just giving a fixed point in time value. But that's okay. It allows us to test that the MIBs are in fact working with OpenNMS. And if you connected it to a real device, you would get more interesting data. But you can see that the data is available. Now, what I want to do is to jump to another way of viewing this data, which is using Grafana. And if I go to the radio main page in Grafana, which isn't but should be set up to be the default login page, you can see that on this page you've got sites which you can click on and jump to. I won't do that in this case. And you've got data specific to each of the sites. So I can choose which customer I want to look at, Independent Local Radio Contractor 1, and I can choose which of the sites that this particular contractor has a transmitter on. So I'm going to pick Fort Whitley, and you can see that then there's a selection of nodes that can be looked at for that site if you want to look at specific data for that. Okay. Also, you can see here that there are all the nodes on that site, and if there were any alarms, they would show up here. And for the device itself, if I click on the Intel NUC, for instance, you can see that the alarms for the Intel NUC would show up here. Down below, you can see these are all of the alarms that are in the system. Again, this depends on what you want to see. So, I've just done enough of a dashboard in Grafana to show how the metadata that comes from Kuwaiba can be used to build a data-driven dashboard. But I'm sure much better dashboards could be created if I put more time into it. And I haven't put all of the data on the dashboard that we might be interested in. But let's look at this Portsmouth radio device. And we're going to jump to a dashboard that gives us the left and the right. And that is based on this particular template, but it's for that foreign source ID. So it's that particular device that I'm picking up the data for, and then getting the left and right. Now you could put more monitoring values on this, but I've only just put 2 at the moment. And if there were any alarms on the site, they would be showing up here, but there aren't any alarms to speak of in this case. So that really summarizes the demonstration. What I have shown you is this is the actual equipment in a real rack, which we've simulated. And then I've shown you that the simulation itself contains OpenNMS, its database, the provisioning integration server, and Kuwaiba. OpenNMS is talking to the simulated network equipment using 4 minions. That means that OpenNMS thinks that there are 4 sites out there from which it's getting data, and that allows us to see the data coming into OpenNMS. I have not provisioned OpenNMS in any other way other than asking it to request a requisition from the provisioning integration server, and the provisioning integration server has asked Kuwaiba for that data. So that concludes the short form version of this demonstration. I will do another video which talks in more detail about the actual modeling in Kuwaiba and how that is done. Thank you.